Hello and welcome to the next installment on TPI ECUs and the supporting parts thereof. I just want to briefly touch on knock control and Memcals and the relationship between knock control systems and Memcals in these ECUs, specifically the speed density 1227730 ECU. That's the one we mostly concern ourselves with. So when it comes to the conversion from a mass airflow system to the speed density system, there's a couple of considerations that you have to make. We only touched on it briefly in the previous videos, but one of the important things that needs to be considered is how are you going to deal with knock control? Because on the mass airflow system from 85 to 89, knock control was dealt with one of these modules. The knock sensor went to this. This filters the signal from the knock sensor and then sends a signal to the ECU. The ECU then processes that and decides what to do in terms of retarding the timing if it senses knock, etc. So this is what exists on the mass airflow cars. That in 1990, when they went to the speed density computer, they did away with that. And instead, they replaced it with this module here. So this module became integrated into the Memcal. And this is just one of those modules that's been removed. This ARDC Memcal this is just a 2.8 liter, I believe, from 2.8 liter V6. So it's not directly compatible with the TPI engines that we're talking about, although it can be adapted to it. So here I will pop the cover off of this one. So we just removed this cover, and what we have here is this was the original Memcal from the mass airflow car. I've modified it because, as you can see, basically, actually should be oriented like that. This EEprom is what originally was here, but I've desoldered the EEprom and soldered in a EEprom, which is electronically erasable programmable read-only memory, as opposed to a EEprom, which is an electronic programmable read-only memory. The difference between these two is effectively, if you wanted to reflash this with a modified program, it could be done, but it's very cumbersome and time-consuming to do, because what you have to do is remove this piece of tape, and I don't have one removed here, but anyways, what you can see, if you remove this piece of tape, you'll see actually the chip. It's a clear piece of glass, and underneath is the chip. All right, I decided to just illustrate this for anybody that's not familiar with these things. Here is an old EEprom. You just peel that off. And what you see underneath is this. You are basically looking at the die in there. So what this means, as I said, you can program these. But what you need to do in order to program that is you need to use special piece of equipment that very few people actually have anymore, called an EEProm eraser. And this is essentially a ultraviolet light, a high intensity ultraviolet light. And what you do with it, because before you flash a new program onto this thing, you need to erase it first. And the way to erase those EEPROMs is to cover it up with this, hit the start button, and you wait, I don't know what it is, like almost a half an hour for the most part. Sometimes you have to do it twice. So it could take you up to an hour to erase these things. And then once you've erased it, you need a special, sort of a specialized piece of equipment. Again, something that not everybody's going to have. Something like this. A programmer, a EEPROM programmer, which this is what I actually used to use to program EEPROMs as well, but it will do EEPROMs. And you need to set up the proper settings for the specific chip that you're trying to flash as well. Anyways, my point is, it's a very cumbersome process and not something that most people are going to do anymore. This is like 1980s technology, well, 70s technology really, but it kind of went away in the 80s. So what I have done in this case is I've upgraded to this EEPROM, which is more like 90s technology. So still pretty outdated, but better than that. This you can erase and reflash in literally a minute. The erasing process is done through that other piece of the EEPROM programmer I showed you, hooked up to a laptop, and that will erase it in literally 20 seconds. And then it probably takes another 20 seconds to flash the new program onto this thing again, and it can be done over and over and over again. So the difference being this, it can be done within about a minute. That one over there would take probably half an hour to an hour to flash the program every time you want to make a change. So that's what I've done here. There's various different ways to attain that. So using an adapter similar to this one is probably going to be your best bet. These can be had from a company called motes.net. They've recently come back on the scene. They were out of business for a few years. There's also a company called Boosted Northwest that sells a very similar product. I'm not sure how much they're selling these for. We're certainly under $100 for this adapter, probably about 60 bucks. I'm not sure exactly. But what this allows you to do is essentially, it allows you to use an EEPROM in a removable ZIF socket. So the way that works is you just lift up that lever, then you can take your chip out, take it over to your EEPROM burner, burn the new program on there, then bring it back over here, drop it in there, flip that over, and then you're good. So obviously much easier than using or trying to burn one of these things. The other thing it does is allows you to put a Memcal as a pass-through on here, and by so doing, if you have a Memcal that has, obviously that has a knock filter on it, if you're going to use perhaps a stock, if you have a stock Memcal from a 90 to 92 TPI V8 car, and you are going to use the knock filter from that, then you just plug it in like so, and it works as sort of a pass-through. It uses that, this will then allow it to, it'll use the program off of here, but it will use the CalPack circuitry and the rest of the Memcal circuitry, and the knock filter will be used for all their functions but all the program will come from here, and it will bypass the EEPROM. So the EEPROM will then take precedence, and it'll bypass what's in the EEPROM, but it will use everything else on the Memcal. So yeah, this thing highly recommended. It's pretty much it's pretty much a need to have thing if you're going to do any sort of tuning on these things. There's as I said before, there is other ways to get around it, but this makes your life a lot easier. And this just plugs into your. You have to take the case off, but then the case cover off, and then you plug that in there. So that's how that works. Highly recommended that you do it this way. I built this just because I wanted a spare, and at the time that I did that, Motes had actually gone out of business. They are back in business again, and these were at that time not available, but now they are. So back to what we were talking about in terms of the knock control. So this is the old way. This is how it was done with the speed density computer. Now what I did when I converted to the 1227730 speed density computer, I chose to maintain the use of this module because it's already in the car, and it's relatively easy to wire this up to the new computer. And by doing that, you negate the need to go out and get a tune port injected 1227730 Memcal, which to get the proper Memcal, for that application for a Camaro or a Firebird or a Corvette TPI, you can't get them from GM anymore, but they can be had on places like eBay. But they usually run, if you can find them, they usually run around $300, $250, $300 if somebody has one for sale. So rather than do that, what I chose to do was to maintain the use of this thing, and actually the Memcal itself. This is the original MAF 1227765 computer Memcal. You can't use them right out of the box with the new computer, with the speed density computer, but if you change the chip, because the chip's capacity is bigger, if you change the chip, then you can use the actual Memcal body. Now, I guess we should back up a little bit and explain why you would even consider doing that. These chips here on these Memcals, and you can see the same thing exists on this stock speed density chip or Memcal as well. These are what's called the CalPack chips. They provide a limp home mode in the event that something goes wrong with your EEPROM. Effectively, it was a good idea in theory, I think, but it very rarely ever comes into play. If something was to go wrong with your EEPROM, or in this case your EEPROM, and the program inside here became corrupted, in theory you would still be able to get home. You would still be able to drive your car home. It would still drive very poorly, but it would drive on these sort of analog chips, which would still fire your injectors and give you basic rudimentary ignition timing control in your engine. That's kind of the idea behind these chips. And these are specific to the engine size that you're using. In other words, This particular one being a V6 Memcal, these chips are not really likely to run your 350 TPI engine. Or if they did, they would run it probably worse than than this one would, which is this one's spec'd for a V8, because this was a 350 TPI MAF Memcal. So these chips are V8 chips, are spec'd to run a V8. This one is not. That's what that's essentially the difference between these Memcals. Are these CalPac chips, and it's in the event of a limp home mode situation where you're relying on these to get you home, this is going to be calibrated to run a V8 engine, your 350 or 305, whatever it may be. So that is the main consideration with these different Memcals. In practice, I can think of only maybe one instance in all the years that I've driven these cars where this has come into play. And it's extremely rare. Yeah, sure, it did run, and I was able to get home. But it's not that big a deal if you were to just not worry about this and go with your V6 Memcal, because this is not going to happen very often. Extremely rare instance. So that being said, what you can do, one of the things, let's explain first what this resistor here is for. The other consideration is the difference between the mass airflow and speed density computers. Not computers, but the mass airflow and speed density cars use a different knock sensor. And the difference is that in the speed density system, the computer is looking for a knock sensor with approximately 3.9 k ohms of resistance. That's what it's expecting to see. If it doesn't see that, it's going to throw a check engine light. The mass airflow cars, on the other hand, use a knock sensor which has a 100 k ohm resistance. So when you switch the computers from a MAF car to a speed density computer, unless you go ahead and change that knock sensor as well, your computer is going to be expecting to see a 3.9 k ohm resistance in the knock sensor circuit, and if it doesn't see that, it's going to throw a check engine light, and the knock sensor and the knock circuit will not be working. So what we do, it's a fairly simple thing. If you wish to maintain the use of that stock knock sensor, the 100 k ohm knock sensor from your MAF car, and use it on your speed density computer that you've now swapped in, you simply need to put a 4 k ohm resistor in here across these two pins. Do that, and the computer will now see that 100 k ohm knock sensor as a 4 k ohm knock sensor, and now you don't have the check engine light being set, and it still works correctly. So that's one of the things that so anyways, that's what this resistor is for. That's one thing that you will need to do if you're going to maintain the use of the original knock filter. So now, another scenario here. Let's say, again, you don't have the V8 TPI Memcal, and you don't want to spend the $300 to get one, but you do have a V6 or a 4-cylinder Memcal, which were a lot more readily available. They came in all kinds of different cars. What you can do in that case, pretty simple. You can uh, jumper a couple of pins, and that will well, it won't fake it out, but it will set this Memcal up to fire as a V8, as a V8 Memcal would. And this is specifically the pins that we're concerned with, right? That's all you need to do is just put a jumper wire, solder a jumper wire in there, and then this effectively will fire as if it was a V8 Memcal. You still will not have the proper knock sensor circuit here. I just want to stress that. Even if you do put this jumper in, this Memcal, assuming you change this program to the proper TPI program, this will now effectively run your car perfectly fine as a V8 TPI car in your 1227730, but this knock filter is not tuned for a V8 because this was a V6 car. This was from a V6 car. So this knock filter is not correct. Which is why, as I stated previously, in my case, I decided to use the stock knock filter setup, the external stock knock filter, because I didn't have a V8 Memcal, and I wanted to keep having knock control in the engine. What you could do in this case, you could, in the tune, just turn off knock control and not have a knock sensor. That would be perfectly fine. And in fact, your engine, assuming it's tuned half decently, you would never notice it anyway. Just make sure you run the right octane of fuel, and you would probably have no problems or issues of any sort. The other possibility, which you could do, is you could theoretically remove this knock filter, and then if you manage to get hold of one from a V8 car, because these can be just desoldered. If you manage to get one of these from out of a V8 Memcal, you could then solder it onto here, and theoretically that should then give you knock filtering for a V8, tuned for a V8. Where you might get one of these is the Memcals from 94 to 95 TPI trucks had a very similar Memcal. The chip was different, but it did have this same knock filter. And if you supposedly, I've never done it myself, you could desolder the knock filter from one of those and solder it onto your 1227730 Memcal, and you should then have a proper V8 knock filter. Again, that's theoretical. I've never actually done it. What I have done in the past is desoldered this, removed it completely, and then turned off all knock control in the program using Tuner Pro, and I've run that without any issues whatsoever for many years and many miles, and never had any issues. So in order to do it that way, you can use a V6 or a 4-cylinder Memcal. All you need to do is this. You need to put this jumper in, solder that in place. That will then make this fire like a V8, and effectively everything then will work just perfectly fine. I think that pretty much covers everything I wanted to go over. That pretty much covers the gist of knock control on these engines and these computers. Those are the things that you really need to consider. All right.